And then you get to see all the modules. The first thing I actually did, based on this particular course and one other in the certificate series, is I reorganized this. So all of these on the left-hand side, all these individual modules, what I did was I rechunked them. I took it apart and sort of reorganized the content. So it corresponds to the book, but it's not necessarily linear. It makes a little bit more sense, and it's a little bit more organized. The thing I really redid for the class, though, is the module on interpolation, because this is a module that gives the students the most trouble, at least so far. So what I did, I give it the name. I try to make it a little bit amusing, the mathematical one, not the musical. And then I put in the reading right up front so that they know what they should have read and where all of their resources are. Now, the book for this happens to be online, so they do not have to buy the textbook. And that was under the intro section on the original piece. Up here, they can get the textbook. The first thing that I changed was I created 4 TED Ed projects. TED Ed was the thing that I evaluated before. They've actually updated TED Ed so that now you can have up to 15 questions for their section. You're not just limited to 5 the way you were. I like to think, perhaps it's a little bit of hubris, but I like to think that I helped move that a little bit and increase that number because I did send them a couple of emails asking why it was limited and if it could be increased. I asked for just 10, 15, is pretty good for just about anything. If I click on these, of course, the first one is, basic curve fitting, interpolation, and polynomial interpolation introduction. This is a very short video, right, but it is extremely well done and explains the limitations and the structure of the material. The second one, let me open all of them, and then we can look at it. The second one, direct method of interpolation, linear interpolation. This is basically, you've got a bunch of data, and you take that data and you want to fit a straight line to it. And then within that line, you want to predict data points or values that are between any of the data, right? So you've got data, say, here, and you've got data there. On the bottom left and top right of this video, and you want to interpolate, or you want to know what the value of the data point is right there where that red box is. Once you know the line that fits that data, you can predict what that value is. Of course, the more data points you have, the better off it is. This particular video from Numerical Methods guy, this gentleman is another college professor, and what they did was they got an NSF grant to develop numerical methods as an online course. And they developed their own book. It's a totally online book. It's not the one I use, but I reference their book and use it as a supplement. They also have all of the videos for all of the chapters, right? So if you click on Numerical Methods guy, you would go and get all of the videos that are possible. I reference all of his videos in each of the classes, but it seemed like by the time they got to interpolation, they were not watching the videos. All right, so the TED Ed piece is my way to try and get them to watch the videos, all right, because under the Think, for this particular thing, I've got 3 multiple choice questions. I'm looking for them to answer something specific about the video that they have seen and that they have read so that they put it all together. I stress to them that the videos are the only way for them to get an active lecture. Otherwise, what they get is they get videos of me, but it's a screen capture video, and I'm showing them how to utilize the software to do interpolation. Same thing, direct method of interpolation, linear interpolation. It's the second video from this guy. And then there's quadratic spline interpolation. Again, if you take a look down here, it's the same gentleman. It's still numerical methods guy. But again, I'm trying to get them to think of, okay, the data doesn't fit a straight line, right? Can it fit some type of polynomial? And in this case, it can. Quadratic spline is actually very, very useful. Right? So I pop those right at the top. And then I go in and do a very, very, in this case, very, very short lecture. I'm trying to give them a reason for doing interpolation. And this is sort of, my experience, with the whole thing. Then I have a section called class trips. And most of the time I send them out to various websites to figure out exactly what they should be doing, give them some added benefit, give them some added information. Up here, it just gives them, it's a Wikipedia. I'm not crazy about Wikipedia, but in this particular case, it gives them a really good working definition and some examples, right? And examples for me are a huge thing. I want them to have as many examples as possible outside of their textbook so that they can put it all together to make it useful. Right? So I try to give them a lot of class trips, external information aside from the book. Some of these YouTube videos are repeats of, the TED Eds. Not all of them are. I sort of mix and match, right? So I'm hoping that they're going to click on these and say, oh, well, this is this. I've already seen it. Right? But this one is different. And so I don't give them in any particular order so that I try and get them to click on everything. These last two under MapleSoft are, because we use the Maple software package to do interpolation. Actually, I tell them they can program. Java, C, C++, doesn't matter to me. They can write code in Maple, or they can use an Excel spreadsheet. And what I have here is the Maple piece to try and explain how to do curve fitting using polynomial interpolation and what commands you have to type in Maple to get this to work. And of course, down here, the nice piece is, of course, Maple gives you actual examples of what to do, right? So here, you tell it you're going to use curve fitting. You ask it to do polynomial interpolation on this data using that variable, and it tries to give you a polynomial that fits the data. In this case, the polynomial that fits the data is a straight line. This one is, using Lagrange. There's different kinds of stuff, that you can do with this. There's also a whole different section from Maple for, polynomial interpolation. And notice that it gives you different methods here. You can actually tell it what method to use, whether you want Hermite, Lagrange, Neville, or Newton. This one is actually a little bit better because what you can do is you can take the same data set and do multiple interpolations from it, get multiple, results, compare the results. And in my world, what we do is I graph them all. And I have them graph them all. So that they can see, okay, well, there's my data. This is this one. This is that one. This is the next one. And those two are really bad. This one works. So I try and get this. Now, the bottom piece is where I also changed this. It used to be just assignments. And then under exam/projects, what I did was I had a multiple choice exam, an online multiple choice exam. It was, in essence, 50 questions, and the computer chooses 25 at random, and they would have to take this. And it was time limited and all those things, but I was really looking for something different. And so I took heed for that section. That's actually that's the section I reviewed as well. And for this particular piece, because they were having such trouble with it, I decided I was going to change it from an exam to projects. And I had research data, and I had data from various and sundry things, but I also had my own research data from when I was in graduate school. So what I did was I took that and I constructed 3 basic project questions. Up here